Hello everyone! In this lesson, we're going to talk about collisions. First, open our Dragon Breath ribbon. Let's take a look. Here we have two bones. They have some basic motion. So for collisions, they're mainly controlled by this set of parameters. Here we have three types of collision shapes. These are some collision parameters. First, let's create a sphere. Take a look. For example, here we have a sphere. Let's give this object some motion. Let's see. First, look at how it collides with the sphere. After it hits, it won't pass through. Look at this sphere. The one we use most is probably the capsule. Let's move this sphere aside. Create a capsule. We can directly scale it. Like this. As long as it's in the scene, it will perform collision detection. It slides past. Take a look. This capsule, we can also lay it sideways like this. Let's see what effect that gives. That's it. It just rests on top. There's also a center name. Here are two parameters. The first one is sampling density. What is sampling density? Because we're using bones. When bones detect collisions with objects, if the bone is very long, I'll recreate one. Recreating it will be easier to understand. Let's say the bone is this long. When it does collision detection, it might just pass straight through. It won't have a collision point. By increasing the sampling point density, we can interpolate points in between. That way, the detection becomes more accurate. Let's also make a simple animation. Sorry. Move it up here. Let's make a simple animation. We increase the sampling value. That's equivalent to adding 5 more detection points in between. We can see the same result. It detects the collision. Above is the solver steps. Solver steps means, if it's set to 1, it checks collisions once per frame. But if this object moves very fast, in this frame it's still here, in this frame it's still here, and in the next frame it's already over there. That means it never gets a chance to detect a collision. At this point, we need to increase this value. For example, checking once every 1/10 of a frame. That way we can do the same simple test. Let's say this frame of the animation is here. Delete this frame, and in the next frame it jumps over here. That's way too fast. It moves a long distance in just a few frames. In that case, it won't be detected, or it might be detected incorrectly. So we need to increase this value. For example, set it to 10. Let's take a look. After increasing this value, the calculation will be slower because it's checking collisions once every 1/10 of a frame. We can see it still catches it here. Let's look here. Why does it still pass through? Actually, there are some points in the middle. They might be here, but the point below didn't collide. So it still goes from this point to that point. So if our bone is very long, there can still be some interpenetration. But the basic collision effect is there. This is collision between capsules and spheres. Another type of collision is planes. I'll move this aside first. Where are planes used? Especially for the ground. For example, skirt dragging effects. Here I've made a swinging object. I'll add a plane. Let's scale it up. When it swings down, it goes into the plane. Then we move it up a bit. I'll reduce this value a little. This is too big. It's rotating too much. One step is enough. We can see it lands on this plane. It won't fall through. We can also duplicate this plane. Note that this plane has an orientation. After duplicating it, we need to rotate it. Only its positive z-axis direction is the direction that can collide. Let's run the solver. That's our explanation of collisions. Thank you.